Dear students, today we'll see the topic from unit 3. First, initially we'll see the introduction to induction motor, the concept of speed and slip of induction motor. In the previous class, we have seen the last topic of speed control of separately excited DC motor using a chopper. We have solved some numerical problems for calculation of duty ratio, speed, back EMF, and power of chopper fed DC motor drive. Now, coming to the third unit, today we'll see on the concept of speed and slip of induction motor. By the end of the session, you should be able to describe the performance of induction motor based on speed and slip. We have studied about the induction motors in electrical machines course. A three-phase induction motor is largely used for commercial and industrial applications. There are two types of induction motors, the squirrel cage type and slip ring type of induction motors. In both these, we have stator and rotor. The stator of squirrel cage and slip ring type of induction motors are of same construction. The stator will be having a three-phase winding. The stator will be having three-phase winding. And coming to the rotor, the squirrel cage type of induction motor has closed path of the rotor winding with the thick copper bars placed in the slots. And these copper bars are connected at each end by end rings. In case of slip ring type of induction motor, the rotor construction is similar to that of the stator, and hence it will also have three-phase winding, normally star or availability for connection to delta. So the stator is star connected in both the case, but the rotor construction is different. Based on that, you have the names squirrel cage type and slip ring type of induction motors. The advantages of induction motors, why they have to be used for real-time applications, because as compared to DC motors, induction motors are very rigid. Particularly, these advantages can be listed for this squirrel cage type of induction motor. As we have very rigid construction of rotor, the motor is very rigid and can be transported from one place to the other place. Lower maintenance requirement, better reliability, lower cost, weight, volume, and inertia. So as compared to DC motors, induction motors have very large number of advantages. Because of the small size, less number of components, the system or the machine has a high efficiency, and has the ability to operate in dirty and explosive environments. But in case of slip ring type or in case of DC motors, the disadvantage is that because of the presence of external in resistors, slip rings and all, and here in DC motors, we have the commutator presence. The rigidness is not there, but all these advantages can be listed with respect to the squirrel cage type of induction motors. Coming to the DC motors, as I told that the DC motors main drawback is that the presence of commutators, and it requires frequent maintenance for replacing the brushes and all, and it is not suitable for explosive and dirty environments. Hence, induction motors are being replaced by the DC motors, particularly when the AC motors or the induction motors came. They were used particularly for the constant speed operation. Why? Because is the speed control of DC motors is very convenient, and smooth and a wide range of speed control can be obtained in case of DC motors, and hence for variable speed applications DC motors were used. For constant speed applications, induction motors were preferred. So in case of induction motors, if conventional or traditional methods are used for speed control, it was very expensive and very complex control circuit was required. The system was not much efficient as that of the DC motor. Hence, Initially, the induction motors were used for constant speed applications, and DC motors were used for variable speed applications. But as the technology progressed, because of the invention of the thyristors like SCRs, BJTs, MOSFETs, and all, and power transistors, gate turn-off thyristors, the advantage with the advanced power converters like inverters, inverters, rectifiers, that has made the possibility of usage of the power electronic devices and converters to build a good performance and cost effective control circuit. This resulted over a period that the induction motor speed control became very easier with the new methods of speed control techniques, and they are being now replaced by the DC drives. We can see that the present trend motor applications or drive applications is majorly with induction motors. So now let us see the performance of induction motors. So as we have discussed at the initial part that the induction motors, three-phase induction motor has the stator constructed with a balanced three-phase winding. And in case of wound rotor or slip ring rotor, the rotor is made up of three-phase balanced winding similar to that of stator with the same number of poles. So construction of stator winding and rotor winding in case of slip ring type or wound rotor type is same. But in case of squirrel cage type, the rotor is made up of thick copper bars connected or shorted at the end by end rings. So in induction, the same number of phases and poles are produced by the squirrel cage rotor as in the stator winding. Even though the structure is only with the rotor copper bars shorted with end rings, but the number of phases and number of poles produced are same as that of the stator winding number of phases and poles. So that makes it convenient to produce a rotating magnetic field, and hence the torque is produced. Yes, when the stator is supplied by a balanced three-phase AC source of frequency omega radians per second, that is a supply frequency is omega radians per second, a rotating magnetic field moving at synchronous speed omega ms radians per second is produced. So this rotating magnetic field, if the frequency is given by omega ms, it depends on the supply frequency and the number of poles designed in the stator winding. So the stator winding magnetic field will be having a frequency of 2 by p into omega, or that is nothing but 4 pi f by p radians per second, where p is the number of poles. If the rotor speed is omega m, let us say the rotor, because of the rotating magnetic field produced by the stator, rotor starts rotating. Let the steady state speed of the rotor be omega m radians per second. Then there is a relative speed between the frequency of stator flux or stator field and the rotor speed. The difference between these two, omega ms minus omega m, is called as slip speed, omega SL. And this, the difference between these two is also called as the slip speed and is denoted by S into omega ms. So from this, you can write that S is equal to omega ms minus omega m divided by omega ms. So this ratio, the relative speed to synchronous speed, is called as the slip. When you multiply by 100, you get a percentage slip. So if, for example, we know what is the slip of the motor and what is the synchronous speed of the motor, we can find what is the rotor speed by omega m is equal to 1 minus s into omega ms. So we have these relations which are to be used for further analysis of induction motor. So from these equations, what is that observation is the rotor speed and the synchronous speed of the stator field winding will be different. This is because, for example, if the rotor speed is less than omega ms, then the relative speed is positive because relative speed is given by what? Synchronous speed minus rotor speed, omega ms minus omega m. So if omega m is less than omega ms, the relative speed or relative slip is positive. Consequently, the rotor induced voltages have the same phase sequence as the stator voltages. So in the rotor, there will be three-phase voltage generated. That three-phase voltages will be having the same phase sequence as that of the stator voltages. The current produced through the rotor produces a field which moves with respect to the rotor at the slip speed. So the rotor current frequency will be having a frequency of slip speed frequency in the same direction as the rotor speed. So if the rotor is rotating in clockwise, the flux produced by the rotor currents will also be in the clockwise direction. For omega m equal to omega m, if let us say the rotor speed becomes equal to the synchronous speed of the stator field winding, uh, stator field, then the slip speed becomes zero. When the slip speed becomes zero, both the rotor and the flux are rotating at the same speed, and hence there will be no torque produced, and hence the motor stalls or stops. The third possibility is that if by chance we make the rotor speed to become greater than the synchronous speed, then the relative speed will become negative or reverses its polarity. So with that, the rotor induced voltages and currents will be having the uh, uh, opposite phase sequence or reverse phase sequence. And these three-phase rotor currents will produce a field which moves with respect to the rotor at slip speed in the direction opposite to the rotor speed. Now, the flux produced by the rotor currents will be in the opposite direction to that of the rotor rotation direction. So, and hence, this we call it as a negative slip. As the direction of the current is reversed, now we say that the power is supplied from the motor to the supply, and hence the motor acts in generator mode. And this generator mode of operation is employed for regenerative braking. So whenever we want to stop the motor, the back EMF or the energy stored in the motor can be supplied back to the source by making rotor speed greater than the synchronous speed, and hence the motor tries to operate in regenerative braking mode. Yeah, so let us review. Mention any two reasons why DC motors were largely used. Initially, why DC motors were largely used as compared to induction motors? Let's think of, because they are suitable for variable speed control, and they provide smooth and long range of speed control. More efficient and less expensive speed control methods can be implemented. Sensing of speed is very easy. Control of speed is very easy in case of DC motors. Second one, what are the advantages of induction motor over DC motors? So over a period, now induction motors are gaining over DC motors. Why? What are the advantages? Particularly with the squirrel case type, you can list out many advantages. Like it is very rigid, lower maintenance, better reliability, lower cost, weight effective, like that. Induction, yeah. So here we have seen the introduction to the control of induction motor, and we'll see the torque derivation next class. So we have made the comparison of induction motors and the DC motors, and we have seen what is the meaning of speed, slip, rotor speed, stator speed, and stator flux speed, and all, and how these relative speed or relative slip it decides whether it is motoring operation or generating operation. So that's what we have discussed today in this topic. So concept of speed and slip of induction motor. So you should be able to now describe the performance of induction motor based on the slip and speed. Yeah. Please think of these possibilities. Describe the operation of induction motor for the following conditions. Omega m less than omega ms. Omega m equal to omega ms. Omega m greater than omega ms. Where omega m is the motor speed, that is rotor speed. Omega ms is the synchronous speed. As for further understanding, please read chapter 6 of GK Dubey, section 6.1. Thank you, students.